Hello everyone, welcome back to this algorithm with Python series, and in this video we are going to implement merge sort algorithm that we discussed in the previous video. So first of all, let's just take a look at this code. This 3 lines of code has nothing to do with algorithm itself, but because we are going to implement merge sort and we are going to use recursion, so sometimes because of its depth, recursion depth, your Python returns you some errors. So we are just simply increasing that depth right here. It has nothing to do with the algorithm itself. Okay, so first of all, what we will do in this video, we will divide this video into 3 parts. In the first step, we will take 2 arrays, and we will take them as sorted subarrays, and we will stitch them into a bigger array that will be sorted, just like merge sort does from the lower level. I mean, it divides your original array into sub arrays until they become so short with 2 elements, and then it sorts them, and then it stitches back those subarrays, right? So first of all, what we will do, we will just take two subarrays that will be sorted, and then we will create a function which will stitch those two sorted arrays into a bigger array, and that bigger array will also be sorted. In the next step, we will actually take one array that is unsorted, and then we will utilize that function that we created in the step first to sort that one single array. And in this step, we will actually go ahead and write a function for merge sort itself. But in this step, we will use a new array that will store the sorted array elements. But because we will be creating a new sorted array, so it's not very efficient when it comes to space complexity. So we don't want that. We want our code to be as optimized as possible. So we want to sort our original array in place. That means we don't want to create a new array for that. So in the third step, we will create our sorted array in place. We will not create any new array. We will take the original array and we will sort that original array in place. So let's just go ahead and move to the first step. First of all, I will create 2 arrays, and for that I will simply create a body. If a name is equal to main, if that's true, then I will have a list A, and this list A, let's suppose we can take random numbers like 12, 14, 16, 18, and 20. We have 5 elements in it, and then we will have a list B. So let's suppose it's 22, 24, 26, 28, and 30. And what we will do in the first step, we will take these two arrays, and we will treat them as sorted subarrays, and we will create a function that will stitch these two arrays into a bigger array that will be sorted. So I will write a function for that. Define merge two lists, and here I have to give my lists. I will give list A. You can use any argument name here, but I'm just going ahead with the same list names here. Okay, so that's we have created a function, and now we have to write the body of this function, right? So first of all, what we have to do is we have to create a sorted array. Remember, I said that in the next step, when we will try to sort our lists, we will store that new sorted array into a newly generated list, right? So let's say we have a sorted list, and it will be empty, of course. Then we need a length of both of our lists. So we can say length of A is equal to length of list A, and similarly for B we will find the length, and we have list B. Now we also need pointers as well. If you remember, when we were stitching subarrays, we were comparing the leftmost elements of both subarrays, right? So, for example, here I will compare my 12 with my 22. Now, 12 is the smallest, so we will remove it from here and we will add it into our sorted list, right? And after that, our pointer will move from 12 to 14 in list A, right? So that means we need pointers as well for these lists. So I will create I is equal to j, and we have this 0. I'll just correct this, right? So both of these pointers are starting from 0, and then they will move as our elements will be removed from these two subarrays, and those elements will be added to our newly created sorted array. So we will write a loop that will actually go through both of these lists. We will say that if I is less than length of A, obviously, and j is less than uh, length of B, right? So when this is true, then only then check for the elements if they are smaller or bigger, and then based on their position, you will add them in your in this sorted list, right? Okay. So first of all, I will check if list A is ith element. If that is less than or equals to list B is jth element. If that's true, then we have to remove this element from the subarray and add it to the sorted list, right? I mean, if it's the small number, then obviously it will come first in the sorted list, right? So for that, I will just call my sorted list that we have just created, and in this list we will append our list A ith element, right? And after that, when we remove this element from subarray, then we have to move the pointer from this to next element. So in this case, our pointer is I, so we will just go ahead and increment I in it, right? I by 1. Okay. Now if that's not it. If it's the opposite case, that means our list B's element is smaller. Then this element will be removed from the list B and it will be added to our sorted list, right? So we will simply just go ahead and call our sorted list, and we will say that this time you have to append list B's jth element, right? So we will call list B and J. And similarly, just like I, the j pointer will move from one element to the next element in subarray. So we can simply do increment here. Okay, so that's it when we have to compare. But we can also have condition like, for example, if we have let's say more elements here, right? So this array has I mean more elements than this array. So what should happen that until this until this number of elements we have to compare both lists, right? But after that we don't have any element in list B. Then all of these elements should I mean should be added as it is in this sorted list, right? So for that, to check these elements, we have to write while loops for each of these lists separately. So I'll just go ahead and remove this, and we can write while I is less than length of A, then just sort that ith element from list A to sorted list, right? And after that, just like above, we have to increment our I. And same will be the case for list B in jth condition. We will say that if j is less than length of B and list B's jth element should be appended to list sorted list, and we will just increment this j here. Now at the end, we have to return that sorted list that we just created now, right? So we can simply say return sorted list. So that should be it. I will just go ahead and print the output of this function. So for that, first of all, I will call my function that I just created, and to this function, I will give my list A and list B. So I'll save this program and let's run it and see if this works. So you can see that both of the arrays have been stitched together and the output is in sorted form, right? So step two is clear, right? I mean, right about now we have subarrays. Sorry, step one is cleared by now. Right now we have two subarrays and we wrote a function that is merging them and creating a new bigger array that is sorted, right? But now we have to write a merge sort function uh, to I mean which will take a single array and that single array will be unsorted, and then it will divide that list into sub list itself, and then it will sort it, right? So we will just go ahead and comment this out, and we will take a random list here. For example, we will have 47, 100, 33, 22. Let's say we can have 450, 1000 even. Okay, so we have to write a function that will take this one single list and it will divide this list into subarrays itself, just like we had these two lists, and then it will sort them accordingly. So I can just simply go ahead and remove this for now, and we'll create a new function here. We can have def merge sort. This is the function, and this function will take an array. uh, okay, so we have to take this array, and then we have to divide this array into sub arrays, right? So first of all, we will divide this array on the basis of midpoint. If you remember the last video, we were dividing each array into sub arrays based on the midpoint, right? So we have to create a midpoint first of all. This is mid is equal to length of array, whatever the length will be, divided by 2. It will give us the midpoint, right? So now we will have two parts of the array, the left array and the right array. I mean, left array on the left of midpoint and right array on the right of midpoint. So for that, left is equal to array. So it will start from the beginning and it will go to till midpoint, right? And same is the case for right, but it's just opposite, that it will start from mid and it will go to the end. So we have just I would say divided our list into uh, left and right subarrays. But now we have to divide our subarrays into further subarrays, right? Until we reach the low level, which will have only two elements per subarray, right? So we can use recursion for that. We can say that left will be equal to merge sort that we just created, and it will take left. So it will divide the left into further sub arrays, and same is the case will be for right. So we'll have merge sort for right. Great. So now we have subarrays, right? And we created this function to handle the subarrays, right? Before we had two arrays, and then we merged those two arrays using this function, right? So similarly, we have two subarrays here, and we will use this function to merge them. So or in other words, to stitch them together. So here it is. We can simply say that return, and you can call your merge toList function that you created earlier, and you can give it your subarrays, left and right. Okay, so I think this should be fine. Oh, yeah, we have to take care of a base case. I mean, if your list does not contain any kind of element, or it has only one element, then your list is already sorted. Then you don't have to do all of that. So you can just create a check here. You can say that if length of array is less than or equals to one, sorry, less than or equals to one, then just return the array. I don't want to do anything because it's already sorted. So I'll just save this program and I will clear this prompt. And we have this unsorted array. Oh, remember we have to print our result as well, right? So I will say that merge sort, and to this I will give my list A. Uh, Instead of printing the value directly, I can just simply save it into a variable. And here I have just taken a test variable A. Okay, so I'll just save this program and we will run it and try and see that what is our answer. Now here you can see we had a single array that was unsorted, and your two functions that you created above for merge sorting sorted your original array, right? So your output is sorted. We have 12, 22, 33, 47, 100, 450, and 1000. So your code is working pretty good, right? Your merge sort is valid, or it's working absolutely fine. But here's a catch: we are creating a new list here. So that means your space complexity is not constant, and that's a bit of an issue. I mean, especially for a larger number of lists, you will run out your memory, and that's not efficient. And if you're solving this question in a coding interview, you are probably gonna fail in that interview. So we have to come up with a solution in which we don't create a new list. Instead, we sort our list in place. So we can just simply go ahead and comment this out, or we can simply remove it. Okay, so what we have to do is we have to, on each step, after comparing the elements of subarrays, we have to put them in the original list, right? I mean, for example, if list A's ith element is smaller, so it will come first, right? So we will put it or replace the element of original list with this element. So that means we also have to keep track of all the elements in the original list as well. And for that, we are going to need another pointer k, right? And we will also have to read the original array, right? That is the only way we can keep track of the elements of array, right? So we will also read array here. Now, if the list A's ith element is smaller than list B's jth element, then this time instead of sorting, what I have to do is I have to replace that smaller number with the element in the original number at that place, right? So I will simply just go ahead and I will say that array of k, it should be replaced by list of A ith element, right? So this is simply all I have to do. I have to just replace that position's element in the original array with the smallest element between subarrays. That's the only thing I have to do. And this increment, ith increment, will work exactly fine. On the other hand, when list B's jth element is smaller than list A's ith element, uh, then that means we have to remove that jth element from list B, and then we have to replace your original list element with this element, right? Because we are doing inline sorting. So we are not creating any kind of sorted list, right? So we can simply remove this, and just like above, we can say that we are removing or replacing our kth element from original array with list b's jth element, right? Because this is the small number, and it should be replaced by this original array's kth element. Okay, and remember that we are moving in our subarrays, right? So if list A's ith element is smaller, then we remove it from that list, and we replace your original array's element with this element, right? And we do the same thing with list B. Okay, we are moving inside the subarrays, and we are incrementing their pointers as well. But we have to remember that we are also moving in our original array. I mean, after we replaced this element with this element, what we have to do is we have to go to the next element in your original array, and then do all of this all over again, right? So we also have to increment our k pointer as well, because we are also moving our original list. So what you can do is you can simply go here, you can write k increment 1, and you can also say that k plus equals to 1. We are incrementing your k pointer because we are moving uh, to the next element in your original list or original array in either of these cases, right? So because we are no matter what the case is, we have to increment this k, right? So instead of writing this individually in each condition, you can simply go outside of this condition, and you can increment your k here. So that's how you will iterate or go to the next element in your original array as well, right? So the same thing will happen here. We will remove this sorted list because we are not creating any, and we will write that array of in your original array, your kth element will be replaced by list a ith element, and then we will increment your I pointer, but we also have to increment your k pointer as well, because we also want to move to the next element in your original array. And the same thing will happen here. We will say that array of k is equal to list b j, and we will again increment our k here. Okay, remember we are not creating any sorted list, new list, right? So we don't have to return anything. So we will just remove this. And now we have to update this function as well, this merge sort function that we created. Right. So remember that we are not creating any subarray, right? We are just implementing our algorithms. So you don't have to write this. So what happens will be that whatever you have created in this function will be implemented to this variable. So right, and it will be done in inline, right? So you don't have to create variables now. So you can just simply go ahead and remove this as well. Okay, and you don't have to return this as well. And now remember that your merge to list was taking three arguments: list A, list B, which were the subarrays, and your original array as well. So you can simply call your original array here. Okay, we have to do a little bit of updation here as well. Okay, now before what we were doing is we were taking our list, your input list, and we were implementing your merge sort on it, and then we were creating a sorted list, and we were storing it into array, into A, right? But now we are not creating any new list. We are doing this inline. So all you have to do is just remove this, and this algorithm, whatever you have written in this function, will be implemented on this list. And after this list A will be sorted, because we were doing it inline, right? So this list A itself will be sorted. So we don't have to store it into another variable to create a new list. right? Because that's where that's what we were actually trying to prevent, right? To make this code uh, a little more optimized when it comes to space complexity. So that's why this time you don't have to print your A, you have to print your list A, because we have sorted this list itself. We have not creating any new list that is sorted. So what you can do is just save this program and run it. So here you go. You have your sorted list here, right? This original list was unsorted, and the answer now that you have is a sorted list, right? So you have successfully implemented your merge sort on your unsorted list. So this merge sort, what it actually did was it divided your array into subarrays, and then those subarrays into further subarrays. And at the low level, when each subarray had only two elements in it, it sorted them, and then after sorting them, it stitched those subarrays together, keeping that in mind that the resulting array should be sorted as well. So whatever we discussed in the previous video, we have implemented here so far. So I hope you are familiar about merge sort and how we can write its code and how we can implement it, uh, and how we can implement it using Python.